So we're going to be writing the inequalities needed to graph the constraints regarding pizzas and soda pop purchases. So here we're going to let our pizzas cost $6 and a six-pack of soda cost $2, and we have $100 to spend. So first we need to write an inequality to represent the number of pizzas we can purchase for $100 or less. Well, we're going to let x represent the number of pizzas. So 6x has to be less than or equal to 100. Then we're going to write an inequality to represent the number of six-packs of sodas that we can purchase. Those were $2 each. Y will represent the sodas, so 2y is less than or equal to $100. And we need an inequality to represent the total purchases. 6x plus 2y has to be less than or equal to $100. Now, remember, we can't purchase a negative number of pizzas, so 0 is our minimum quantity for our x's and y's. I need to divide here by 6, so 0 is less than or equal to x is less than or equal to, let's find out, 100 over 6 becomes 16 2/3. Well, here's the thing. Am I allowed to buy 2/3 of a pizza? No. That means I can buy up to 16 pizzas. Here I need to divide everything by 2. So y has to be less than or equal to 50, and that's fine because I'm allowed to buy 56 packs of soda. And then with this equation, when it's time to graph it, I need to decide, am I going to work in y equals mx plus b form? If I am, I need to subtract 6x from both sides. So 2y is less than or equal to negative 6x plus 100. Divide everything by 2. So y would have to be less than or equal to negative 3x plus 50. Or I could graph it using intercepts with zeros. If I plug in a 0 for x, that's gone. The y value has to be 50. And if I plug in a 0 here, that means my x value has to be the 16 2/3 that we found before. There we go. So now I've drawn myself a set of axes, and I need to sketch the graph to find my feasible region. Now remember, this one here, because there's only an x, tells me I'm going to be graphing vertical lines. Because there's two values, that means there's two vertical lines. I need to do the vertical line representing that 0 is less than or equal to x, and I need to graph the line x is less than or equal to 16. Here's the graph of my vertical lines. X equals 0 is the y-axis. I just came out a distance, labeled it 16, drew my other vertical line. If this was the only set of constraints that I would graph, I would shade in between them. But I have 3 more lines that I need to graph. Next, let's do 0 is less than or equal to y is less than or equal to 50. Again, this is really 2 different lines that we're going to graph. These are both going to be horizontal lines because we have a y and a constant value, no x term. Y is equal to 0 would be the x-axis, which is already drawn for us. To get y is equal to 50, I just came up a distance, marked it as 50, and drew my horizontal line. Now if I was going to shade between these 4 constraints, I would be shading this rectangular region. But remember, we have one more set of constraints, in this case a single line, to graph. Now I could use the slope-intercept form, but personally I think that the intercepts will be much easier to graph. Okay. This intercept, 0, 50, matches 2 other constraints that I've already done. But down here, our point that was at 16 2/3 and 0 is outside the other existing boundary. So we don't really have a triangle. We actually have this funny quadrilateral. Now remember, we need to label the corner points of the actual feasible region. One that is obvious is here at the origin, 0, 0. Another one which is obvious is right here at 16, 0. This one right here, I know it goes out 16, but I don't know how high up yet. Let's come back to that one. And then up here, this point, of course, is at 0, 50. Well, this one is on my diagonal line, and I know that the x value is 16. Let's come up to the equation for our diagonal line, and let's plug in 16 for the x and find out what the y value would be. So, negative 3 times 16 plus 50, y equals negative 48 plus 50, y equals 2. So apparently, this other corner point is at 16, 2. And I'm finished.